In this video, we will learn how to solve equations like this. Understand that we are given the value of a trig function and we're being asked to find the angle that would give us that value. There will be two answers because we're being asked to find the angle that's between 0 and 2 pi. That's a full revolution, and depending on the reference angle, there are always 4 angles that will give us this value, except 2 are positive and 2 are negative. So if it's positive, there will be two angles that will give us the same answer. Now, the cosecant is the reciprocal of the sine function. So this equation tells us that the sine of theta must equal 3 over 2 radical 3. Now, the only thing that makes this even slightly difficult is because they're writing it in a form that we don't usually use. At least we haven't been doing it in class. Let's rationalize the denominator to make it look like what we're used to. In other words, let's get this radical out of the denominator. I can do that by multiplying in the numerator and the denominator by radical 3. Now if I do that, in the numerator I've got 3 radical 3. Okay, now I've got my 2. I'm just going to bring that down. Now radical 3 times radical 3 is just 3. Okay, just like any radical. Radical 7 times radical 7 is 7. Radical 13 times radical 13 is 13. You get it. Now I could multiply these together and get 6, but it would be even more convenient just to realize that these 3's are going to just cancel each other out. So what I actually have right here is that the sine of theta is equal to radical 3 over 2. Now this is the form that we're used to. So the sine of what angle is equal to radical 3 over 2? Well, that's pi over 3. Now that means that the reference angle is pi over 3. Alright, to get the actual angles, there will be 2 of them. It's useful to look at a unit circle. So I'm going to draw one. I could cheat and look at a filled in one, and maybe I'll do that afterwards. But you can always draw one. So since the reference angle is pi over 3, I'm going to draw some pi over 3's like we do. Alright, so these are my pi over 3's. Alright, these are the 4 positions that have a reference angle of pi over 3. 2 of them will give me a positive radical 3 over 2 sine, and 2 of them will give me a negative radical 3 over 2 if I do the sine. I want positive radical 3 over 2. So the sine value is the y value on the unit circle, and the y values are positive above the x-axis. So these are the 2 positions that will give me my answers. Alright, so that's why the answers will be 1 pi over 3, pi over 3, and 2 pi over 3. So these are the answers. Now I could have cheated and looked at my filled in unit circle looking for a sine or a y value of radical 3 over 2. I see one right here, and that is at pi over 3. And then I see another one right here, and that's at 2 pi over 3. So if you're allowed to use a filled in unit circle, you can just find sine will be the y value, and look, those are the angles you want. Looking at number 3, please understand that radical 2 over 2 is the same thing as 1 over radical 2. So this is what we've been using in class a lot. And we've memorized this, correct? So when they say the cosine of what angle is 1 over radical 2, then clearly that is pi over 4. So that is our reference angle. Alright, so be careful because that's not the final answer, that is our reference angle, is pi over 4. Alright, so you can nail it down by drawing yourself a picture. Okay, pi over 4, so there's pi over 2, and here's pi over 4. Okay, so looking at the 4 positions, alright, these 4 positions have a reference angle of pi over 4. 2 of these will give me positive 1 over radical 2 if I do the cosine, and 2 of them will give me a negative 1 over radical 2. Alright, we want the positive version this time, but cosine is the x value, and x values are positive to the right of the y-axis in these 2 quadrants. So these will be the 2 angles that will be our solutions. And so what are they? Well, we've drawn all these pi over 4s. So this will be 1 pi over 4. So that's one of our answers. But then it goes 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4. Okay, so 4 pi over 4 and 7 pi over 4. Again, if you have the luxury of a filled-in unit circle, you can look for your 1 over radical 2 cosine x value. So there's my positive 1 over radical 2 at 7 pi over 4, and there's my other positive 1 over radical 2 at pi over 4.